Hello, am I audible or not? Just a minute, I'm again sharing the screen, okay? Am I audible now? I'm just sharing the screen, okay? Hello, am I audible now? Am I audible or not? हेलो। नहीं नहीं, मैंने पर्टिकुलर स्क्रीन शेयर करी है, जो एडिटर है ना उसकी स्क्रीन शेयर करी है मैंने। उस पे उस पे दिखा रहा है ये। हाँ, उस पे भी सेम ही यही आ रहा है। मैंने ऑन करा और यूट्यूब वाले पे आके देखता हूँ, तो वहाँ पर केवल एलएम दिखा रहा है। मैंने जो प्रोग्रामिंग वाली विंडो शेयर करी है, तो उस पे नहीं उठा रहा है। होल्ड करके रखना है ना, टाइम ले रहा है ये। आवाज चेक करने के बाद मैं बोलता हूँ। हेलो, एम आई ऑडिबल नाउ? Okay, audible is there. Okay, just a minute, there is some sharing issue. Okay, I just check sharing is not enabled. Yes, yes. हाँ, वापस एक बार ऑफर करके डाउनलोड करूँगा। मैंने सबको चेक करा था एज इट इज। हाँ हाँ, साइड में लिखा आता है, एक मिनट रुको, वीडियो मीट पे क्या लिखा आता है? यहाँ आ रहा है स्टॉप लाइव स्ट्रीम। स्टॉप लाइव स्ट्रीम। स्टॉप लाइव स्ट्रीम ही आ रहा है यहाँ पर, एक व्यू फुल। हाँ हाँ। हेलो। हेलो। Just give the quick confirmation so we can start now. Am I audible now? Am I audible now? Garvit, am I audible? Yes. Okay. So screen is also visible now. Fine. So today we are discussing about the some of the problems. Okay, because my compiler is not working here, but we can discuss about the fundamental concept of these programs. Okay. So first we discuss about the stack. Okay, not stack. We are just discussing about the recursion problem. So recursion is what? I'm just discussing about the recursive problem. So recursion is what? What is the recursion? Recursion means a function which call itself number of time. Recursion is what? A function which call itself number of time. That is known as recursion. Fine. So let's suppose if I want to write a program to find the factorial of the given number by using the recursive function. Factorial of the given number by using the recursive function. For that we have to write the mathematical form. Okay. So I just write the mathematical form and how this mathematical form gets solved. Fine. So I write the factorial of n here. Fact of n, that is equal to what? We write n factorial. What we have to write here? If I write the 0 factorial and then 1 factorial, 0 factorial and then 1 factorial. So what is the 0 factorial? It's 1. What is the 1 factorial? It's also 1. Okay. So first we discuss how you can find the factorial function. Then after that we take one problem on this. Okay. So fact of n is what? It is 1. If n is equals to 0, if n equals to 0 or n equals to 1, n equals to 0 or n equals to 1. Fine. So if I write this way, then factorial of n equals to 0 and n equals to 1 is what? 1. And if I write n multiply by fact of n minus 1 here, n multiply by fact of n minus 1 here, when this condition satisfy, if n is greater than, if n is greater than 1, at that time we can solve this one, n greater than 1. Now let's suppose I want to find the factorial of 5. Now I want to find the factorial of 5 here. So what we have to do here? So what is 5? 5 is a number. So 5 is greater than 1. Yes, condition is true. For this we can write 5 multiplied by fact of n minus 1. So fact of n minus 1 is what? That is fact of n minus 1 is what? That is 4. Now we have to calculate the fact of 4 because this is not calculated right now. So we write fact of 4 here. So fact of 4 is what? We write it as 4 multiplied by fact of 3. 4 multiplied by fact of 3. So we didn't have the value of fact of 3 right now. So again you can write fact of 3. Fact of 3, that is equal to 3 multiplied by fact of 2. 3 multiplied by fact of 2. Now we have to calculate the fact of 2 here. Fact of 2. We have to calculate here. Fact of 2. What is that? You can write 2 multiplied by fact of 1. You can write 2 multiplied by fact of 1 here. And according to upper formula, we can check fact of 1 is what? As per the condition, what is the fact of 1? Fact of 1 is having the value 1 here, as per the mathematical form. So this one we can substitute, this one we can substitute here also. So 2 multiplied by 1, that is what? We have 2 here. And 3 multiplied by 2, 3 multiplied by 2, we can write 6 here. And 4 multiplied by 6, we can write 24 here. And finally we can calculate the value of fact of 5. So here you can write 5 multiplied by 24, 5 multiplied by 24, that is equal to 120. That is equal to 120. So this way you can calculate your factorial program in the recursive manner. Okay. So this gets clear to all of you. If you give the confirmation, then I can take one example for the factorial recursive function. Is this clear to all of you how the factorial function gets solved? We have the factorial of n, that is the mathematical form. Just give the quick confirmation, that is the mathematical form. and we can have the termination condition n equals to 0 or n equals to 1, that is the 1. And if n is greater than 1, then we can find n multiplied by factor of n minus 1. So we can apply this formula. Fine. So let's suppose I want to write one program, okay, in this form. Suppose I want to find the sum of, this series. If I write 1 upon 1 factorial, then plus 1 upon 2 factorial I want to find, plus 1 upon 3 factorial, plus 1 upon 3 factorial, plus 1 upon 4 factorial. That is our program, okay? 4 factorial, then plus 1 upon n factorial. That way you can find 1 upon n factorial. So in this question, what we have to find? We have to find the sum of the particular terms, okay? Now let's suppose I give the terms number as n equals to, let's suppose 3. If I give the n equals to 3, then we have to find the sum of these 3 numbers, okay? So if I write n equals to 3, then what is the sum? You can calculate sum as sum is equals to 1. 1 upon 1 factorial is what? 1. Plus 1 upon 2 factorial is what? That is 0.5. And 1 upon 3 factorial we can write as 1 upon 6. So if I solve this, then we get some result here. Okay. And if I write n is equals to 4 in this case, then what will happen? Then we have to write the sum till n equals to 4. So in this case, you can calculate the sum as 1 upon 1 factorial plus 1 upon 2 factorial, plus 1 upon 3 factorial, plus 1 upon 4 factorial. If I write this way, 1 upon 3 factorial plus 1 upon 4 factorial. Okay. So till now you have to calculate the summation. So number of terms you can take from the user also, and you have to find the sum. Okay. So this problem we can write in a program. Fine. Problem statements, have you understand what we have to do? We have to use one loop counter variable that will count till the number of terms. Okay. So for this we are writing one program in the notepad. Okay. We are not compiling the program because the editor is not working right now, but we can write this into the notepad. So I'm just opening the notepad file and then share with you also. Great. So I'm just writing this particular in the notepad file and then I'm just sharing. Okay. So first I share the notepad file here. Just a minute. Great. So in the notepad file, I just want to write a code which is related to this particular part. Fine. So I'm just open the notepad file here. Now is this visible to all of you, this notepad file? I have shared the notepad file. Is this visible to all of you? Yes. Now this is visible. So you can write a program for the series. What we have to do, I save this file with some extension. Let's suppose I save this file with p1.c here. Now first you can include the header file. So you can write hash include stdr.h. Inside this you can write one factorial function. So for this you can write factorial of an integer. This is the prototype declaration. For factorial function. Because in this series we have to use the factorial function. Okay. In this series we have to use the factorial function. So what we have written? First we have written the header file hash include stdr.h. Then after we have written integer is the return type of the function, fact is the function name, int is the argument for the particular function. So we have written here prototype declaration for factorial function. Fine. After that you can start your program from the main function. So we write int space main, then main code we can write here. In this, what we have to take? We have to take the number of terms, that is n. We have to take the variable loop counter variable, that is I. We have to take the sum variable sum. So n is what? That is the number of term. I is the loop counter variable. Okay. And sum is what? That is the summation of the series. So we will take some variable here n comma I comma sum. Fine. So we start the loop counter variable from I is equals to 1, I is less than equal to n, till n we can run, and then I plus plus. Okay. So I am just writing some code here, and then this code also visible to you within a second. Fine. So I have started one loop counter variable I is equals to 1, I is less than equal to n, and then I plus plus. Inside this loop counter, we have to create one sum function. Okay. Inside this loop counter, we have to create one sum variable, then sum plus, then we have to call 1 upon, then fact of, then you can pass your I variable. Fine. And you can write here 1.0. And what is the summation for the series? You can take the sum variable as the double type, not integer type. So here you can write double sum that is equal to 0. Double sum that is equal to 0. Fine. So sum is equals to sum divided by 1 upon 1.0 upon factorial of I we can write here. And then after you can print the summation variables result. So sum is equals to percentage d comma summation variable. Now what we have to do? We have to write the function definition here. What we have to do? We have to write the function definition here. So how you can write the factorial function in the recursive manner? For this we can write integer as the return type. Fact is the function name, integer n is the argument, and we can apply the condition with whatever we have mentioned. If I write n equal 0 and or n equal 1, then we can return the value 1. Otherwise you can write return n multiplied by fact of n minus 1. It is the recursive function. Fine. So in this case, we have one integer return type. Function name is factorial. Integer n is your number, and we have applied the condition as per our mathematical equation. That is what? N equal 0, n equal 1. Then we can return 1. Otherwise, you can return n multiplied by fact of n minus 1. So this way you can find the sum of this particular series. Okay. Is this clear to all of you? How we can find the sum of this particular series? Yes or no? Give the quick confirmation so I can write another example. Just give the quick confirmation for this. Great. So this is the recursive functions solution for the particular series. We have find the sum. Now we are taking the similar type of example. So I am sharing the MS Paint screen again. Fine. Just a bit. I'm just sharing the MS Paint screen here. Now what is the second problem we can do here? We have to find the sum. We have to find the sum of the given series. I write the sum is equals to, for the given series I want to find. Okay, sum is equals to what? We have to write x raised to power 1 upon 1 factorial plus x raised to power 3 upon 3 factorial. Then we can write x raised to power 5 upon 5 factorial. Then we can write x raised to power 7 upon 7 factorial. This way you have to calculate the sum of the particular series. Now you can write x raised to power 9 upon 9 factorial like that. Fine. So in this case we have the factorial function also. In the bottom side we have the factorial function also. But in the top side what we have the power function. At the top side what we have the power function. So we have to apply the two functions which is in the recursive form. Okay. So factorial we have calculated. Now I want to calculate the power of the particular number. Okay. So I'm just telling how you can calculate the power of the particular number by using some mathematical form. Fine. So I'm just writing here how you can calculate the power of the particular form. Then we can take two arguments as a and then b. And what is the mathematical form for power calculation in the recursive form? We have the power of any number with 0. Power of any number with 0. If you are having the a raised to power 0, then we have 1. If you are having the 4 raised to power, then we have 1. Now, if b is equals to 1, if b is equals to 1, then what is the result? Then we have the number itself. Fine. And if b is greater than 1, if b is greater than 1, then we can find a multiplied by power of a minus a comma b minus 1. So you can write power of a comma b minus 1, a comma b minus 1. So this way you can calculate the recursive function of the power. Okay, so I'm just solving one example here, and then after we can move to the sum of this series using the recursive function. Fine. So I write the power of a comma b. So I write 3 comma 3. I want to find the power of 3 comma 3 by using the recursive function. So what is the 3? That is the value of b. And if b is greater than 1, if b is greater than 1, then you have to calculate according to this formula. So you can write 3 multiplied by power of 3 multiplied by power of 3 comma b minus 1. 3 comma b minus 1 is what? That is 2. So you can also write the power of 3 comma 2. You can write the power of 3 comma 2. Now what we have to write? We can write 3 multiplied by power of 3 comma 1. You can write 3 multiplied by power of 3 comma 1. Now we have to calculate the power of 3 comma 1. So you can write power of 3 comma 1 is what? Power of 3 comma 1 is what? That is the current value of a. That is the current value of a. And what is the current value of a? That is 3. So here you can write 3 multiplied by 3. That is 9. 3 multiplied by 3, that is 9. And you can write 3 multiplied by 9, that is 27. 3 multiplied by 9, that is what? That is 27. So you can calculate the power by using this recursive formula. Okay, and this particular formula we can also write in the programming part. So I want to find the sum of this series. Okay, so for this series, what we have to take? We have to take the value of x here. We have to take the value of x here. We have to take the number of terms here. Okay, so if I write the number of terms 1, 2, and then 3. Okay, so till this you can iterate. Okay, if you have the number of terms 3, then you can iterate till that. Fine. So we have to include from 1 to, if I write n as 5 power, then you can run till now. Yes or no? So I write one program which can find the power also, which can find the factorial also. Okay, and then we can take the summation also. Okay, so I am writing one program in the notepad for this particular series. We have to take the x value and then we have to take the n value. If I take the x value as 1, okay, so what is the sum? So for this you can write 1 upon 1 factorial, then 1 of cube, again we have 1 upon 3 factorial, and plus 1 upon 5 factorial. This way you can calculate. Okay, so if I write n equals to 5 here or n equals to 3, then according to that you can apply your loop. Fine. So I write n equals to 5, that is the value. If I write the 5, then it will move to the till 9 or then till 5, you can make according to that. Fine. So I'm just creating the two functions. One is the power function and second one is the factorial function. Fine. So I'm just sharing the notepad screen again for another example. Just wait. So for this particular series, what we have to do? We have to include again the header file. Okay. So you can write hash include stdi.h. That is the header file which we require for the printing statement. Now what we have to write? It is a main function here. And before that we have to write the function prototype. Okay, so int, we have to create one function factorial, and second we have to create the power function here, and you can pass integer and integer as a argument. So we have to declare two prototype here. one for the factorial function calculation and second for the power function calculation. And in the main function, what we have to write, we have to take the value of x, we have to take the value of n, we have to start from I. So you can write the loop I is equals to 1, I is less than equal to n, and then I plus plus. Inside this, we have to calculate the summation for the given series. So sum is equals to sum plus. So we have to write the power of x comma then i's current value. So i's loop you have to increment by 2. I's loop you have to increment by 2. So you can write x sum plus power of x divided by x comma I divided by factorial of I. So this way you can write, and you can convert this number into the double type. Any of the number you can convert into double type. And summation variable you can also take in the double type. So double sum, and you can start with 0. Okay. And before that I write one message here, enter any value for x variable, enter any value for x variable. So for this you can take scanf function percentage b address of x. Okay. Now what we have to take? We have to take the number of terms also. So printf enter any value for number of terms. So you can write scanf function percentage b comma address of number. That is for number of terms. So I have to run this loop from I equals to 1 to number of terms. Okay. And then after you can print the summation also. So printf then sum is equals to percentage b, not b, we can write percentage f or lf. If I take the double variable, then we have to write lf. Okay, in the previous question you can also change the format specifier. So we write the sum here because we have declared the sum as the double type. If I write the sum as the float type, then we can use the format specifier as percentage f. If I take the double, then we can take the format specifier as percentage lf. Now you can print the summation of the given series. Okay. So I write return then 0 here. So we have to create the function definition for these two functions, power of x comma I and then factorial of I. So for this, what we have to write, integer power int a comma integer b. As per the mathematical equation, you can write your formula here. So if b equal 0, then you have to return the result as 1. Fine. Else if b equal 1, then you have to return the number as a. Else you have to return the number a multiplied by power of a comma b minus 1. This way you can calculate your power function. I have told how this internally gets calculated in the MS Pen. Now same we can write the factorial function. So you can write integer number you can collect in n variable, and inside this you can write if n equal 0 or n equal 1, then you can return 1, else you can return n multiplied by fact of n minus 1. So we have implemented two factorial function one factorial function and one is the power function. Now this is the correct for taking the summation. Is this clear to all of you? Because we have to use the x raised to power I. And if I is 1, then next time I is 3, next time I is 5, next time I is 7. So according to that, the power gets calculated. And same time you can divide with factorial of I. Yes or no? Is this clear to all of you? This concept? Just give the quick confirmation so I can move to the next problem statement that is related to the stake. Arvit, is this clear? So we have created power calculation here, then factorial calculation here. And then we have find the summation here. And then printed the value. So this is the sum of the given series which I have mentioned in the MS Paint. Just give the quick confirmation so I can move to the next one. So I'm sharing another MS Paint file, not other MS Paint file. I just save this file with p3.c. Okay. Am I audible and screen is visible now? All of you? Just give the quick confirmation. So I'm just telling first the concept of stake, then we will write the program for the stake also. Okay. So I'm just writing this p3.c file. Okay. So what is the stake? I will just discuss, and then after I will write the program for the stake. Okay. So stake is what? Stake, it is the data structure. It is the data structure which works on first in last out, first in last out, or last in first out, last in first out mechanism. Fine. So we have some functions which is used for creating the stake program. So we have the push function. Push is what? It is used to insert a new element, at the top of the stake, new element at the top of the stake. If I write the pop operation, then we can write the pop function. It is used to remove that topmost element from the stake, topmost element from the stake. And third one is the peak function. Peak function is what? It is used to print the topmost element of the stake. Peak is what? It is used to print the topmost element of the stake, topmost element of the stake. Then we use the peak function. And fourth one is the display. It is used to display the elements from top to bottom. So for this, we are just using the for function for the stake implementation. Fine. So stake is what? It is the data structure which works on first in last out, or then last in first out. So we have four functions. One is the push function, second one is the pop function, third one is the peak function, and fourth one is the display function. So first I write the push function algorithm. Okay, and according to that we can write the program also. So algorithm for push function. What is the algorithm for push function? If you are inserting a new element at the top of the stake, then first we have to check the stake is empty or not, or stake is full or not. Okay. For the push function, we have to check stake is full or not. For the pop case, we have to check stake is empty or not. Okay. So if I write the push function, then first you have to check the stake is full or not. So for stake is full, then we can write the condition if top equal to max minus 1, then you have to print stake is full. Okay. If stake is not full, then you have to increment the top variable by 1. Increment top variable by 1 by writing top is equals to top plus 1. Top is equals to top plus 1. Now third, store the number at the top index of the stake. So for this you can write stake of top, that is what? That is number. And fourth condition you can return from the particular function. So these are the four conditions we can use for the push function. Okay, initially what we have, max is the constant. We can define the max like has defined max and then size 10. Okay, so max is the constant, we can write as 10 here. So if we have the top variable as max minus 1, then this is the condition for the stake full. If the stake is not full, then what we have to do, we have to write top is equals to top plus 1. Initially top is at minus 1, then we starts from the 0th number index. So initially we have to store this index number 0 and new value. Okay, so this is the case for the push function. Now algorithm for pop function, if I write, so what is the condition for algorithm for pop function? So for that, first you can check the stake is empty or not. Stake is empty or not. So what is the condition for checking the stake is empty or not? If top equal minus 1, then you have to print stake is empty. and then return, and then return. In the second case, you have to pick the topmost element. You have to pick the topmost element of the stack. Element of the stack. So for this, we have to take one number variable, and you can write stack of top element. And finally, you can print the number. Now, in the third statement, you have to decrement. You have to decrement the top variable by 1. Okay, for this you can write top equals to top minus 1. And finally, fourth, you can write return statement. So this is the pop algorithm. Okay, so according to this algorithm, we can write the program for the stack also. Okay, so for the peak function, what we have to write? We have to directly print, and we have to check the stack is empty or not. So I write the algorithm for peak function. So what is the algorithm for peak function? First, you can write the condition the stack is empty or not. So I write the condition stack is empty or not. Now in the second case, you have to directly print the topmost element of the stack. So for this, you can write you have to print the topmost element of the stack. Element of the stack. That is what print stack of then topmost value. So this way you can calculate, and then third you can return from the program. Fine. So this is the algorithm for peak function. Now I write the algorithm for display function. So for display, what we have to do? First, we have to check the stack is empty or not. First condition, what we have to check? We have to check the stack is empty or not. Now second condition is what? If this condition not satisfies, then we have to iterate the loop from top to 0th number index. Now you can print the elements from top to 0th index. Top to 0th index. So for this, you can write for loop. I is the loop counter variable top. I is greater than equal to 0. I minus minus. This way you can write the printf statement and percentage d backslash t comma stack of I. Stack of I. So this loop will print your program's output in from the top to bottom side. Yes or no? Is this clear to all of you this till now? We have written the algorithm for display function here, algorithm peak function here. The algorithm is important because we can convert this algorithm into the programming also. Either in C program, C++ program, Java program, whatever program we have, we can write this way. Fine. So if I write the program for this, so I can write the function only. You can call these function directly. Okay. So how to write the function definition here? So let's suppose I want to write the function definition as void. Function name is push integer number. Okay. So this we can write as if top equal to max minus 1. Then what we have to do? We have to write the simple print statement printf stack is overflow, and then return from this block. Return from this block. If this condition not satisfied, then we can write the else statement here. So in the else statement, you can write top is equal to top plus 1. First, you can increment top by 1. After that, you have to print percentage d backslash t, and then what we have to write? Not we are printing, we have to write the stack of then topmost value equals to the given number. Fine. So void push is the function name, and we can pass the integer number here, and number is what? That is passed from the main function. So we can check the first condition. If top equal to max minus 1, then stack is in overflow condition, and then return. Else you can write top equals to top plus 1, then stack of top is what? That is the number. So this is the push function. Now I want to write the pop function definition. So you can write pop, and no need to return anything from here because I want to print everything in the pop function. Now first what we have to do? We have to check the condition. If top equal to minus 1, then what we have to write? We have to write the print statement here. So printf stack is empty. Stack is empty, and then return from here. Return. If this condition not satisfy, then we have to take one variable here, that is the number, So you can write num is equals to stack of top, and then finally you can print the popped element percentage d comma the number, and next you can subtract by -1. So that is your pop function. Now for the peak function, what we have to write? For the peak function, again you have to check the condition here. So I just check the condition, stack is empty or not. So if this stack is empty, then you can print stack is empty. Otherwise, you can directly print the peak element. So peak element is what? Percentage d comma stack of topmost element. So this way you can print the peak element. Now I want to print the display function. So I write the display here, and inside this I write one loop counter variable, that is I. So for I is equals to what? We have to store the topmost variable. I is greater than equal to, that is 0, and then I minus minus. Inside this you can write the printf statement. Okay. So printf, then percentage d backslash t, and then stack of ith index. So this loop will print from top to bottom. Okay. Before that you can write the print statement printf elements of the stack. Okay, and then backslash new line. So this way you can write the functions of the stack. So we have written 4 functions for the stack. Is this clear to all of you, this stack operations? Is this clear to all of you, this stack operation, Garvit? So we have 4 function here. One is the push function, second one is the pop function, third one is the peak function, and fourth one is the display function. Okay. In case of push function, we have to insert the element at the topmost index. In case of pop function, we have to remove the topmost element, and then we can decrement the top by -1. And then in the peak function, we can print the topmost element. And in case of display function, we can print from top to bottom. So this is an example for the stack. Now I just move to the part of the queue. Okay, so I just close this part and then open the new file. So what is the queue? I just write queue. It is the data structure which works on first in first out, first in and first out, or you can say LILO, that is last in last out, last in last out. Okay, so queue is having the number of functions here. Queue insert we can implement, then second function we can write queue delete here, then we can write the function name as queue display. Okay, so I just write the insert function definition. What is the definition for this? To insert a new element into the queue at the rear index, Now delete is what? To remove an element from the queue at the front end, and display is what? To print the elements from front to rear end. Okay, so we have to implement these 3 functions. So I'm just writing the code for the queue insert, queue delete, and queue display. Okay, so I write void, then queue insert, an integer number we have to pass. Okay, and now what is the condition we can check for the queue insert? So I save this file with p4.c. What is the condition for the queue insert? First we can check the queue is empty or not. If the queue is empty, then we have to set the front variable and rear variable at 0. Okay, and we can also check the queue is full or not. If the queue is full, then we have to return. Okay, so first condition is what? We have to check if front variable equal 0, and then rear variable equal to max -1. So max is what? It is the size for your array, and front is what? That is the starting index for your queue. Okay, so if I write front equal 0 and rear equal to max -1, then this is the condition for your queue overflow. So I write the printf statement and then write queue is in an overflow condition. Okay, and then you can return. If this condition doesn't satisfy, then initially what we have, front equal minus 1. Initially we have front equal minus 1. Then what we have to do, we have to write front and then rear variable, that is equal to 0. Why we are writing front and rear equals to 0 when the queue is empty? Because I want to start the index from the 0. I want to start the index from the 0 because array starts from the 0th number index. So I write the front equals to rear equals to 0 here. Okay. So when you are inserting an element into the queue, then we have to increment the rear variable by 1. So in the case of else statement, what we have to write? We have to increment rear variable by 1. So you can write rear is equal to rear plus 1. And finally, you can store queue of rear, that is equal to number. This is the algorithmic part and then function part for inserting the elements into the queue. Okay. So what we have checked here? We have checked here the condition for overflow. If we have the queue empty, we have the queue empty, then we can check the front equal minus 1. Then you can make the front and rear equals to 0. And then you can store queue of rear equals to number. So whenever you are inserting an element into the queue, then we have to increment the rear variable by 1. Okay. So this is the function code for the insert part. Yes. Now I want to write the function code for the delete operation. So you can write void q delete. There is no arguments here. So I write here, if front equal minus 1, then simply you can print the queue is empty. Printf queue is empty. And then you can make the return statement. Else, what we have to pick? Then we have to pick the front element into the number variable. So for this, I create one variable as the number integer type. Okay. So I write num is equals to what? Queue of then front, and then I want to print the deleted element. That is what? That is number. And after that, you can increment front by 1. So whenever you are deleting the elements from the queue, then your front variable gets incremented, and whenever you are inserting an element into the queue, then rear variable gets incremented. Okay. So we have one situation in the queue. If the front equal to rear, then there must be at most one element into the queue. Fine. So this is the queue delete operation. Now we want to print the elements of the queue. For this, we can write queue display function. So for queue display function, I write one loop counter variable. Now we have to check the queue is empty or not. If the queue is empty, then we can write the if condition here. So I write this if condition, front equal minus 1, then queue is empty, otherwise you can return. Else, what we have to do? We have to print the values from front element to the rear element. So for this, I write I is equals to front, I is less than equal to rear end, and then I plus plus. Inside this, you can write printf statement %d \t and q of ith index. Okay. Before that, you can write the printf statement elements of the queue. Okay. So \new line. So this way you can find the elements from front to the rear end. So we have I is equals to front, I is less than equal to rear, and then I plus plus. So this will print from front element to the rear element. So this is an example for the display part. Okay. So we have implemented 3 functions. One is the insert function, second one is the delete function, third one is the display function. Fine. So this is an example for the queue. So we have implemented 3 functions: queue insert, then queue delete, and then queue display. You can call these functions from the main function, and by main function you can write the switch cases. Okay. And switch case, there are number of cases. If I write the case 1, then you can call the insert function. If I write the case 2, then you can call the delete function. If I write the display, if I write the 3, then you can call the display function. And in the fourth case, you can exit from the program. So this way you can write the queues example. Fine. Now I'm just move to the linked list part. Okay, I'm just creating one function which is used to insert a new element into the list. Okay, so I'm just taking the linked list. Linked list is what? It is the dynamic data structure. If I write the linked list is what? It is the dynamic data structure. Dynamic data structure. For this, we have to write. For this, we have to create the node. We have to create the node and allocate the memory. Allocate the memory whenever required. Allocate the memory whenever required. So for this, I am just taking one example for singly linked list. How you can write the program for the singly linked list. For this, what is the necessary part? First, we have to create the structure. Step number first, what we have to write? Create the structure. Create the structure for the singly linked list. Singly linked list. So for creating the structure, you can write the struct keyword, struct then node, and then here you can write integer data part, and then struct node star next part. And here I write one variable as start equals to null. Okay, so initially your structure variable will be at the null value. Okay, it is pointing to the null. Now I want to create one node. Okay, so for creating the node, what we have to do? We have to call the function. Okay, we have to call the function void create list is the function name, and inside this I pass the number. Okay, so how you can check the condition here? If you are creating the first node, if you are creating the first node in the linked list, then what we have to do? We have to write the struct node star. Q is the variable and star temp is the variable. Temp is what? That is the temporary node, and Q is what? That is for traversing the linked list. Okay, so initially what we have to check? We have to check start variable if equal null. Then first you have to create the start node. Okay, you have to allocate the memory to the start node. So for this you can write start, then struct not star, then malloc function, then size of, you can write struct node. So this is used to create the memory, or you can allocate the memory to the start node. So if I write the structure variable as the pointer type, then you can use the arrow sign. Okay, for referring to data variable. If you are referring the data variable by using this start variable, then what we have to write? We have to write start of data part, that is equal to number. Okay, and start of next part you can write null. Okay, so we write the starting node as the start. So start is having the data part, start is having the next part. If I write start of data equals to number, then it will print the number also. Okay, and start of next is what? That is pointing to the null. If this is not null, if start is not null, then what we have to do? We have to traverse the list from beginning to till end. So for this, what we have to write? We have to write one q variable, that is struct node start, and you can start from beginning. So you can write q is equals to start. So for traversing the loop, for traversing the linked list, we can write the condition while q of next part, that is not equal to null. So we have to traverse from beginning to end. So you can write q is equals to q of next. Okay, so this is for traversing the linked list. After you can move to the last node, then we have to add the new node. Okay, for adding the new node, what we have to do? Adding the new node at the end of the linked list, what we have to write? We have to create the temporary variable. Temp is what? We can write struct node star malloc, then size of struct node. So this is used for allocating the memory. Okay, so first you can allocate the memory same way you have allocated the memory to the start variable, same way you can allocate the memory to the temporary variable. Now what we have to do? You can write temp of data part, that is equal to number. Okay, and what we have the q variable? Q is at the last node. Okay, now last node of next part is pointing to the null. Okay, now what we have to do? we have to point this queue of next node to the temporary variable, or temp of next node we can write as null variable. So this way you can create your linked list. Singly linked list nodes creation you can write this way. Okay. So I just repeat what we have done. For creating the singly linked list, first you can declare your structure. Okay. And then after you can write your prototype declaration. That is what? Create list and then integer variable. That is your prototype declaration of the function. Prototype declaration of the function. Declaration of the function. And then after you can write your main function. In the main function you have to use the switch cases. If I choose the choice number 1, then you can call this create list function. I directly write the create list function here, internal quotes. Okay, so create list, we have one argument as number type, and initially what is the start? Initially we have the start equal to null. Initially what we have the start equal to null. So if the start equal null, then first we have to allocate the memory to the start variable. Then after you can associate the number variable with the start of data, and start of next we write as the null. In the else block we have to traverse the list from beginning to end, and then after I want to add the new node. So for traversing the linked list, what we have to do, we have to write q equals to start. Where the start variable is pointing, we have to point the q also there. Okay, and you have to traverse the q of next not equal to null. If I write q of next not equal to null, then it will traverse till the end. Okay, till the value null we encounter. Okay, so it will traverse till the end. So q is at the last node. After that I create a temporary node. I can allocate the memory to the temporary node. I can place temp of data equals to number. Now q of next, that is the last node, I point to the temporary variable which I have created here. And next temp of next equals to what? That is null. So this is the function which is used to create the singly linked list. Now what we have to write? We have to display the value. If I write void, then display, then no need to pass any argument here. Now for displaying, what we have to do, we have to write the struct not star q, that is equal to star. I write the printf function elements of singly linked list. Element of singly linked list. That is text list new line. So I write one loop here, that is do while loop. That is do while loop. I write q not equal to null. Till null I can check the condition. Okay. So I print the statement. So percentage d backslash p, and I write q of data part, and then next q is equals to q of next. Okay, so this loop can print the values from beginning to end. So you can start from q equals to start, elements of singly linked list that gets be printed as the console screen, and you can print the queue of data, that is the beginning node, and then after you can move to the second node and check q is not equal to null. If this is not equal to null, then again you can write q of data in the terminal and q equals to q of next. Okay, till you have the nodes, then this loop gets incremented. Fine. Now for creating the beginning, okay, if you want to create the node in the beginning, in the case of singly linked list, what we have to write? We have to write void add bg and then integer number. Okay, so for this, if I write void add bg then integer number, then first you have to create the temporary variable here. Okay, so how you can create the temporary variable here? For this you can write struct not star temp. Now first you can allocate the memory to the temporary variable. Then for this you can write struct not star, then malloc, then size of struct node. Okay, now temp of data part is what? That is number. Now temp of next we can point to the start node. Okay, if you want to add at the beginning, then first we have to create the temporary node. You can allocate the memory to the temporary node, and temp of data is what? That is the number. Temp of next is what? That is the start, and we have to link the start variable with the temporary variable. The start is equal to what? That is the temporary variable. So you can write add bg as the beginning node. Okay, now suppose I want to add the node at the specific position. for writing the node at a specific position. For this, what we have to do, we have to take one argument as the position and second as the number. What we have to write, okay? So for this, I write one function here, add specific function. In this, we write one number and then position also. Okay. So after that position, we want to add the new node. Okay. So for this, we write struct node star q, that is equal to start. So I point the q with the start variable. Fine. I have one loop counter variable, that is I. So you can write for I is equals to 1, I is less than position, and then I plus plus. Inside this, you can write q is equals to q of next. Okay. So this loop is helping to traverse the list till the position. To traverse the list till the given position. Given position. And after that, you can add new node. You can add new node. After that, you can add new node. Okay. So here you can write add new node. So what we have to do for the new node, you can create the temporary variable, that is what struct node asterisk malloc and size of, and then struct node. Fine. So here you can write temp of data part, that is equal to number. Now temp of next, that is what you can write temp of next is equals to q of next. Where the q of next pointing, we can write temp of next. And then finally you can write q of next, we can update with the temporary variable. So this way you can add the new node. Okay. You can create your temporary variable first. You can allocate the memory first. Then you can associate temp of data equals to number. Now temp of next is what? That is the q of next. Okay. And q of next we are pointing to the temporary variable. So this way you can add a specific position. Okay. Now suppose if I want to find the even and odd number sum for the single linked list, so we can create one function, find even add. So I write even odd. Okay. Find even odd. Sorry. So even odd if I want to find with the linked list, so you can write one struct node star q, that is pointing to the start. Now you can use the do while loop. Okay. So I write here do while loop and q not equal to null. So I write the printf function here, but before printing we can write if q of data part that is remainder by 2, if this is equal to 0, if this is equal to 0, then we have to create two variables here that will find the sum or also the counting value. Okay. So I write integer ec, that is the even count. You can write ec equals to 0. I want to find the sum of all the even nodes, then we can write e sum equals to 0. Similar way, you can find the odd count and then odd sum, that is also equals to 0. So if q of data remainder by 2 equal 0, then what we have to do? We have to increment ec plus plus and then e sum plus plus. Not e sum plus plus, you can write e sum is equals to e sum plus q of data part. Q of data part. If this condition doesn't satisfy, then you can move into the else part. Okay. In the else part, you can write OC plus plus and then O sum, then that is equal to O sum plus Q of data part. O sum plus Q of data part. Fine. And then here you can update your variable. Q is equals to Q of next, because I have to move to the next node also. So this is the program which can check the node's value is having the even value or then odd value also. Okay. So it will calculate the even count also, it will calculate the even sum also, it will calculate the odd count also, it will calculate the odd sum also. So after this loop, I want to print all the elements. So I write printf, then even nodes count, that is equal to percentage d, new line, that is ec. I want to print odd node counts, odd nodes count, that is equal to percentage d backslash new line and then oc. Then printf, I write even sum, that is equal to percentage d backslash new line e sum, and then printf I write odd sum, that is equal to percentage d backslash new line, then odd sum. Okay, this way you can find the summation of all your elements. What we have written here, we can count even count, we can write odd count, we can write even sum, we can write odd sum. So this we have written for the single linked list even odd program for the linked list part. Now I want to search an element in the linked list. So what we do, we write search function. Inside this I pass the number here. Okay, so for searching, what we have to do, first we can write the struct node star q, that is equal to start. Okay, now again you can write the loop counter while q not equal to well, till that you can write your loop. Okay, here you can write q of data part, that is equal to the given number. If this is equal to, then what we have to do, we have to write the flag variable. This is used for condition checking. Okay, if you are in the if condition, then flag variable gets replaced with the value 1. If it is not, then we have to write the flag equals to 0. If you have the flag equals to 1, then we can print the position also. So what is the position? You can write pos is equals to initially 0, and but here I write the pos is equals to I plus 1 value. And I is what? I is the loop counter variable here. So I start from the 0. Okay, and then you can write the break statement here. And update q is equals to q of next for moving to the next node, and you can write I plus plus here. So q is equals to q of next is what? It is moving to the next node, and we are also incrementing the position. So after this loop, what we have to check? We have to check flag if equal 1. Then you have to print the element found at that particular location. Element found at location, that is percentage d, comma position variable. Otherwise, you can write else, then printf element not found. Fine. So this is an example for the searching code. Yes, is this okay to all of you? I have implemented number of functions here. I just tell which function we have implemented here. I have write the create list function, which is used to create the node, single node at the end of the linked list. Second function we have created for displaying the elements of the linked list. Yes, that is the elements displaying code. This is for adding the elements at the beginning position. This one is for adding at specific position. Okay, so for adding specific position we have written one function. Fine. And for calculating the even odd, we have written for some logic for the even odd for the linked list implementation. And finally we have written the searching algorithm here for the linked list case. Okay, so this is all about from my side now, because the time is over. Okay, is this okay to all of you? You have some doubts in this section, you can ask. I just implemented the linked list program with number of functions. Okay, otherwise I will stop sharing. Just I give the 2 minutes. Okay, you can ask any of the doubts if you have regarding these functions, Garvit and all these. Or shall I close the session now? Give the quick confirmation, Garvit, if you are here. Great. Okay, no problem. I just stop sharing the live streaming. Okay, fine.